This tutorial contains some basic topics on electronics, including solutions to horizontal size problem of the CRT TV screen. So don't skip the video, watch it until the end. I hope you will learn a lot. After changing the board, we see the horizontal width on the both sides of the screen is often less. But look here. The phase terminal of the horizontal yoke coil is connected to a higher voltage to increase the horizontal size. Even after that, the horizontal size is not sufficient on the screen. In this situation, by adjusting this port, most of technicians increase the output voltage of the SMPS. But if the voltage is increased, then the filament voltage crosses the limit, the EIST current overflows, and the cathode emission increases. As a result, the picture tube is quickly damaged. So, I recommend keeping the maximum voltage to 105 volts. Okay, now let's try to understand why the horizontal size of the TV screen decreases. This is the EIST transformer. It is the horizontal output transistor, and here is the horizontal deflection yoke coil. The horizontal coil is inside and the vertical coil is outside. Okay, now look carefully. This pin of the EIST transformer has a 105 volt or B plus supply, which is the transistor's collector bias voltage. From the horizontal driver transformer, a 15,625 Hz pulse comes to the base. This is actually a sawtooth wave which is amplified by this transistor and output from the secondary coil for the filament voltage and for the accelerator grid. Usually 20,000 volts are produced from here. In this condition, if you apply 115 or more voltage to B plus by the VR adjustment, the EIST voltage will increase to about 22,000 volts or more, which is very harmful to a picture tube. So keep the B plus at 105 volts. Okay, now we come to the point. The two terminals of the horizontal yoke coil are connected here in the circuit. Sawtooth wave are amplified by the transistor and fed into the yoke coil by this terminal, and the other terminal is connected to the ground through the resonant circuit. What is the resonant circuit here? To determining the frequency, a circuit consisting on an inductor and a capacitor in series or parallel is a resonant circuit. This capacitor is connected from the collector to ground. It is the damping capacitor. If the value of this capacitor is increased, the resonant frequency will decrease. So the magnetic field of the yoke coil will increase. Then if the value of this capacitor is reduced, the resonant frequency will increase and the magnetic field of the yoke coil will decrease. Now let's look at the role of the horizontal yoke coil and its magnetic field in a cathode ray tube. It is the parallel connected horizontal yoke coil, the electron gun, and inside of the CRT screen. When the filament of the electron gun is heated, a beam of electrons is emitted from the cathode and falls on the inside of the screen. Then when the coil receives a bias voltage from the transistor like this, the magnetic pole of the yoke coil throws the electron beam to the right side. And when the coil receives the reverse voltage, the electron beam will move the right side. At 15.625 kHz frequency, this horizontal line is scanned in 64 microseconds. In this condition, if we reduce the value of this capacitor, as a result, the resonant frequency will increase, magnetic field will decrease, and the horizontal line scanning time will be reduced. So, the size of the horizontal line will become smaller while scanning in a short time. So, if the capacitor value is low in the resonant circuit of the horizontal yoke coil, the horizontal size of the screen will be small, and when the capacitor value is slightly higher in the resonant circuit, the horizontal size will increase. So, to increase the horizontal size of the screen, we can connect a 2.2 kpf capacitor from the collector to the ground of the horizontal output transistor like this. Okay, connect collector to ground. Look at the screen. The horizontal size problem has been resolved.